Hello guys, good evening.
Good evening,
Have
sir.
you guys practiced any problems?
Yes, sir. Sir, having doubt in two problems, sir.
Yeah. Then forward it to me.
Yes, sir.
What is your native stiffness, sir?
Yes, and which one you are talking about?
Sir, both the problems, sir. 0.10 and 111, both.
Just a second, it's getting loaded.
Yes, sir.
They should start a new PPT. It's taking a long time. So, can you tell me where is the doubt in the first one?
Sir, they are asking to find reaction at B, sir.
Yeah, for somebody, what they give is that they have give a continuous beam and they have given the flexibility matrix and they are asking to find the reaction at P.
Yes, sir.
Right? So what is the equation that you can use? What is the relationship between forces, flexibility, and displacement? Sorry guys, sorry for the delay.
This displacement by force, sir.
I times 1, 2, 2, 8. And they're asking that, did I share anything? I've been writing without sharing. Just
Green is not visible, sir.
yeah, I'm just writing the
Yes, sir.
without sharing. Is it visible?
Yes, sir.
Yeah. Now see, this is all the beam they have given, and they're asking that if support B, it is settles by an amount delta by EI. You have to find out what is the reaction at B. Why it took so much trouble here? See, now let's see what is the relationship between displacements and forces. You know that K into delta will be equal to force. Or what you know, if it goes to the right side, flexibility matrix times force matrix, that will be equal to delta. Are these two equations okay? Stiffness into force equal to, stiffness into displacement, force matrix, flexibility into force, that will be equal to displacement. Am I right? What they have given? They have given us the displacements, isn't it? Now, what is the displacement vector? That I can write it down. Delta 1, delta 2. What is the delta 1? What is given in the question? B settles by an amount delta by A. Degree of freedom considered is upward. It settles by downward. Then what is the displacement that you have to consider? As it is opposite to the sign, minus delta by EA. I think
Or are you writing, sir?
0. Right?
Are you writing something, sir?
Yeah.
Sir, not visible.
No, sir. It is not visible for us.
Are you able to see the screen?
White screen. We are
Sir, able to see the screen, sir, but we
Okay,
can't
now?
see your writing, sir.
now okay, sir.
Okay. Yeah. This is the beam they have given. They have said that B settled by an amount delta by A. Obviously, it is settlement, it is in the downward direction. We know the relation, right? What is the relation between displacement forces? Stiffness into displacement. This I can consider as a relation. If stiffness goes to the right side, that becomes a flexibility. So flexibility times force equal to displacement. So according to the given question, first of all, what is the displacement matrix? Displacement matrix I can represent it as delta 1 and delta 2. Given that B is settled by delta by EI, as it is in the opposite direction, minus delta by EI. Nothing is talking about C. So what is delta 2? 0. Right? What they're asking about? They're asking about the forces. So I will use this equation. Or as they're talking about flexibility, if I want to use this equation, what I will do? I will do my force matrix that will be equal to inverse of flexibility into displacement. What is inverse of flexibility? It is nothing but a
Stiffness.
if this is your flexibility matrix, can you tell me what is your stiffness matrix here? I will reverse this first of all. 3EI times these two will interchange 8(1) minus 2 minus 2 divided by what is the determinant of this matrix? 8 minus 4. Is it right? Is it the stiffness?
Sir.
Right? Now apply here. If I substitute here 3EI by 4 times 8 minus 2 minus 2 1. What is the displacement matrix they have given according to the question? Minus delta by EI divided by 0. That will be is equal to the force matrix, right? That applies. What about your what is the force matrix? Nothing but a F1 and F2. Reaction at 1 and reaction at 2. From this, what is my reaction at 1? Multiply this, how much you will get it? 3EI by 4. If these two multiply, then how much you will get? Minus 8 delta by EI. These two 0, right? So these two gets cancelled, these two gets cancelled. Minus 6 delta. So what is the reaction at B?
Minus 6 delta.
I think
Delta.
it's also direct question, right? What's the difficulty that you have faced? I don't know.
They're given that settlement, no, sir. Got confusion in that.
It doesn't. If that settles, how does it matter? It's like the displacement is along the direction of B, right? Nothing. Have we done nothing new? Anything new? Or we have discussed? Is it same?
Yes, sir. Yes, sir.
It's just the application, right?
Yes, sir.
Okay, just take that you guys are practicing. That's great. And remember, in first shot, nobody will understand. Nobody will get the knowledge of application. And what is the second question? They're asking about, let me write it down. This is what the coordinates they have given. That is R1, V1, or let's say there's a displacement. Let us say this is 1, this is 2, and this is the direction they have given. This is L comma EI. This is L comma EI. This. Yeah. What they're asking is that they are asking F12. So first of all, can you explain me what is F12? They're asking the flexibility coefficient.
Inverse, right, sir?
First of all, where they are applying force and where they are finding the displacement.
At one
At
force.
2, yes, applying force, sir.
They are applying the unit
Displacement. At 2.
unit displacement.
At 2, sir.
So what is the stiffness first of all? Force by delta. If I say it in the form of formula. If I am talking about Kij, what does the first one represents?
Force.
Force. What does the second one represents?
Displacement.
Movement or rotation.
If I'm talking about flexibility, what is flexibility?
Inverse of del divided by force.
Is it okay? Whatever the thing we have written,
Yes, sir.
right? Now, give me an idea. That means they are applying unit force along the direction too, and they are asking us that if you apply unit displacement at 2, sorry, if you apply unit force at 2, what is the displacement that is happening at 1? Can you give me an idea how can I solve this?
So first, we can find out the stiffness matrix, and that is stiffness coefficient, and we can take the inverse of it. Can we do like that, sir?
You can do that also, no issue. Let's say that if I can find out K12, what will be my F12? It is just a reverse of it, isn't it? 1 by K12.
Sir.
No need to find out the whole stiffness matrix and then you have to take inverse and take the corresponding solution. No. Even it is applicable for a single value. It's right. Now, can you quickly find out what is the K12? I've given you, these are your corresponding degrees of freedom that I can give you.
Or it will be 4 EI by L, sir.
No, why it's 4 EI by L?
There will be unit rotation at 2.
There will be.
Sir, we are providing you, it is 4 EI by L.
What is the degrees of freedom that I have given you? In this case, the degrees of freedom I have given you is that?
Vertical, upward vertical.
Then in that case, how can we consider it? Isn't it?
Yes, sir. Yes, sir.
Then how can we approach it then? Okay, now let us forget about with respect to stiffness. I'll just come back to that. Can you give me an idea? How can I solve this? Or else let me discuss one thing. Okay, let me take this problem only and explain it to you. Let us see the application of method of consistent deformation or displacement compatibility. Okay. Now let us take a beam and let us say I am interested. What is the static indeterminacy first of all? If I want to solve it by using displacement method, what are the unknowns that I have to consider? Kinematic indeterminacy. If I want to solve it by using force method, we have already discussed, we have to take the static indeterminacy. First of all, can you tell me what is the static indeterminacy for this case?
2, sir.
2, right? So choose any 2 unknowns. So for the simplicity I will choose these 2. Let us say this is my R1 and this is my R2. Okay. Now imagine if R1, R2 are not existing. First of all, remove the supports. And what will happen? Can you tell me? First of all, if I release those 2, how it will deflect? This might have deflected like this. What about this displacement? Delta 1. What about this displacement? Delta 2. How R1 will exist? If R1 is existing such that it will not allow any delta 1. R2 will be corresponding to along the direction of delta 2. Right? Now, let us say that, tell me initially, do we know what is the magnitude of R1 and R2? Do we know the R1 and R2?
No, sir.
0, sir.
All right. First of all, tell me, is this diagram okay? What I have done first of all? Before that, if you want to clarity, imagine if there is a proper cantilever. Did you remember how we have found this reaction? How we have found this reaction by using the force method? What we have did first of all? We have removed the support. If we remove the support, what will happen? There will be deflection will happen. After that, what we'll do? How to apply the reaction force. Because of this, let us say, this is an amount delta. If these 2 are compatible, or because of this proper support, what is the deflection at this point? 0. If deflection is equal to 0, then what we should do? We have to apply this logic that delta is equal to delta. Did you recall this case? If you want me to explain, let us start with this example. Let us say there are some arbitrary loading acting on the beam. So first of all, we want to solve this by using the force method. If you want to solve this by using the force method, what is unknown quantities we have to consider? We have to consider static indeterminacy. So in this case, we know what is the static indeterminacy?
1.
1, isn't it? So we have to choose one number. So for the simplicity, what I will do, I will obtain this reaction at B. We have already discussed whether if you have remembered why this is useful, because solving things for a cantilever beam is easier, right? Now, what is the next thing we should do? The first thing you have to, as we are talking about the displacement compatibility, first of all, remove this support. If you remove the supports that you have taken as the indeterminacy, how it is going to deflect? So this is one of deflection at point B due to applied loads. So after that, what you have to consider? You have to consider the reaction at B. If you consider the reaction at B, how on the displacement? This one you will get the displacement. So this is what the displacement due to the reaction. We know what is the net deflection at point B because of the support. Net deflection is 0. That means deflection due to applied loads. That should be equal to deflection to the reaction forces. As of now, any doubt in this equation?
No, sir.
No, sir.
Right? Now, tell me, can I find out this magnitude? By somehow, by using some method, can I find out that magnitude? Imagine if there is UDL acting on this beam. Can you tell me how you're gonna find out delta AL? Tell me of one method that I can find the deflection at 3N. I think you guys definitely might have discussed in strength of materials. I'll definitely think.
W divided by AU.
What is the easiest method, or if it directly given the exam, which method you're gonna solve this to get the deflection at pre-end? If you are not saying this, then it will be some troublesome. So
There is direct formula, sir, but forgot.
every time we don't get the direct formula, right? But somehow can you tell me, or based on what method you can apply? You can say unit load method, you can say conjugate beam method. If you want to find out the displacement, then these are the two methods that should strike your mind. Even we have discussed the unit load method for solving the deflection at the trusses. If you remember, summation capital P small p L by AE, and also I have told you integrals if it is for a beams. Okay, now what about delta R? Let us say you know how to find out the deflection by using unit load method or by using conjugate beam method. Now tell me one thing, that can you find out the delta R? I will say I cannot. And you must ask me why. Because do I know the magnitude of RB? If I don't know the reaction at RB, can I find really what is the displacement at that point? I'll get some equation in terms of RB, right? But I can't directly get how much it is happening. So that's why instead of applying the RB, what I will do is that instead of applying some RB, what I will do, I will apply an unit force. If I apply an unit force, can I find the deflection? It's a magnitude. Are you guys facing some trouble understanding these things? Can you tell me where you guys have struck? As you guys are not speaking, I think you guys have struck somewhere seriously. Am I audible?
Yes, sir. Yes, sir.
It was stuck actually. If you guys let me know. As you three are only attending, let me know. It's fine. If you can tell me, it's fine.
Sir, is there any easy method to solve that, sir?
Which one? For which
Sir,
problem?
which one you are explaining now? So
This one.
please teach us in that stiffness method, sir. We'll find out the stiffness and take the inverse of it because we are familiar with the taking stiffness, no, sir.
No, this. No, I'm not talking about in specific to that problem only. I'm talking about in general. I thought of discussing these things today
Okay,
also.
sir.
It's not about the problem. As luckily you have sent me, that's fine. It's somehow correlated. But it's there in my today's list to
Yes, sir.
explain these things. So you guys speak to me and tell me if you are facing the problem, okay? So
Yes,
what
sir.
is our target here? If you are using the force method, our target is to find out the RB, right? If you find out RB, what you can do? Someone let us say that you somehow found the RB. What is our next step? The remaining unknowns we can find out using the equilibrium equations, isn't it? See, we are just discussing. I don't know whether why you guys are today. So for that, what you have to do? For using the application of the force method, we have to use the compatibility equations. Compatibility equations defines nothing but a because of the boundaries. Now, if I look at the joint B, as we already know what is the support, roller support. So what is the deflection? Net vertical deflection at that point, 0 because of the roller support. Is it right?
Yes, sir.
Right. Now, let us apply this equation on this problem. On the first case, what you have to do is that remove the, or what we have to do? Release. We have to remove or release the reactions that we have selected. So what is the reaction? We know that static indeterminacy is 1. If static indeterminacy is 1, we have to select one unknown. So what is the one unknown that we have selected? RB.
TRB.
So unknown you have selected, first of all, release it. If you release it, ultimately what's going to happen? The deflection is going to happen, right? So what is this deflection? This is the deflection due to which forces? Applied loads or applied forces. There is no doubt about it, right? Now,
Yes, sir.
what you have to do? To balance it, the reaction should act in the upward direction, RB. How much it should act? Let us say that is the deflection due to the reaction. The reaction will develop at point B such that until and unless your vertical deflection at that point is 0. That means deflection due to the applied forces less deflection due to the reaction forces must be equal to 0. Is it okay? As of now, this case,
Yes, there is.
one is down and another one is upward. One is positive and another one is negative. If you add, you will get it as 0, right?
Yes,
Now,
sir.
if you remember, can you tell me what is the cantilever subjected to point load? If you remember, the deflection formula will be RB into how much it will be? A cube by 3. Now, if you know this magnitude RB, then only you are gonna find out delta R, isn't it?
Yes, sir.
If you don't know the RB, can you find out what is your delta R? You cannot. Everything, whatever the value you will get in terms of RB, isn't it?
Yes, sir.
This is just a simple one static indeterminacy. Imagine if there is a static indeterminacy of 10. Every time it's not easy to write in terms of RB, RA, whatever the unknowns, isn't it? As here it is having only one unknown. That's why you are directly representing in terms of RB. That's and you are going to find out the equations. But if you are having more number of unknowns, then you cannot apply or you cannot visualize the same kind of thing. So instead, what I will do, instead of applying a force of RB, what I will do, I will of magnitude 1. If you apply force of magnitude 1, then obviously it's going to deflect. According to our terms, what I should call this one? I am applying a unit force and I am finding the displacement at one point. What I should call this one? Can I call it as a flexibility? What is flexibility? Can you please recall? Or somebody, can you please explain? What is meant by flexibility?
Displacement due to unit force.
So that's what I'm doing, right? I'm applying the unit force and I'm finding the displacement. That's why I can call it as a flexibility. At what point I'm finding the displacement? At B. And at what point I'm applying the unit force? At B. Is it okay? Can I represent this as FBB?
Yes, sir.
Right? Now, first of all, tell me, because of the unit force, let us say that it is deflected by an amount 2 mm. Isn't it? Because of unit force, it is deflected by 2 mm. If I apply a force of RB, or forget about RB, instead of 1, if I apply a force of 10, can you tell me how much deflection is going to happening here?
20 mm.
20 mm. Is there, if for 1, it is deflected by 2. For 10, how much it will deflect? 10 into 2, 20. Okay. Instead of 10, if I apply a magnitude of RB, how much it's going to deflect?
RD.
So what is the 2 here? Nothing but the flexibility matrix. So here what I am doing, I am replacing this term. How? First of all, my delta, that is nothing but deflection due to applied forces, plus I am replacing this. How can I replace this term? If I apply the unit force, it is deflected by an amount FBB. If I apply a force of RB, how much it's going to deflect?
2 mm.
RB times
FBB.
that will be. This you can find out by using unit load method or conjugate beam method, any type method. This also you can find out. Why? Because if you apply unit force, can't you find the deflection? You can. Then from this, what you can do? You can find out your RB. That is nothing but a deflection spread by flexibility matrix. Is it right? Doubt in this method? Is it clear, crystal clear? Or if you are having any doubts, let me know. Because this is the heart of the problem that we are going to discuss now. If you don't have any doubt for, we'll go to the, okay. Now, that are involved here, if you want to use the flexibility method or consistent deformation method, what are the methods that are involved? What is the first thing you have to do? You have to find out this one. You have to find out this one. Then only you can find out this one. How can I find out this one? What is the first step you have to do?
Release the reactions.
Yeah, first find the static indeterminacy. After that, select the unknowns. After selecting the unknowns, what you should do? You have to remove or release the forces. If you do that, what is the next step? Find out the deflections due to applied forces, and then find the flexibility matrix, and then find the required unknowns. Is it okay? The procedure that I discussed now?
Sir.
Select the unknowns, find the indeterminacy, select the unknowns, release them, and then find these magnitudes, and then find the required unknown. Is it okay? The flow chart or the procedure?
Yes, sir.
Clear, right? Now, in this case, what is the difference between them? What is the example that we have seen, and what is the difference that we're going to discuss now? Previously, what is the indeterminacy? 1. That's why it is very much easier. Now, what is the static indeterminacy now? In this case, if you can tell me the answers, then I'll be quite easier. I can concentrate where I have to. What is the static indeterminacy? Static indeterminacy, guys. It seems like you guys don't know how to understand this flexibility matrix method. What is the static indeterminacy? I will be keep quiet until you guys say that. Only 3 guys. What's the problem? If you don't want to, I can say I can wind up the syllabus. What is static indeterminacy? Common question, you know, right? What is the static indeterminacy in this case?
2, sir.
So, first of all, we have to select them. Imagine that I am selecting the static indeterminacy as R1 and R2. After selecting them, what we should do? After selecting the unknowns, according to our procedure, what we have to do? We have to release them, right?
Yes, sir.
If I want to release them, imagine it is only resisting the vertical forces. I have released it. It is only vertical forces, that's why I removed it directly. Now, if I release that, what will happen? This is the delta 1 and delta 2, or let us say, these are the due to applied forces. Let us applied forces might be this one, might be this one. After that, what is the procedure? What's the next thing that we should do? Here you can tell me what is the first thing we have first. Unknowns. We have selected it. We have removed them. After that, we have found the due to applied forces, due to unit load. Now, how many steps we have reached here?
2, sir.
2, sir.
And what is the next step that we have to do?
The delta.
We have to apply the flexibility values, right? Now, first of all, imagine that I have applied the unit load here. How, what can be the deflected shape? This might be the deflected shape, right?
Yes,
Isn't
sir.
it? Now,
Yes, sir.
how can I represent this value? Along the coordinate 1. Here I am measuring the displacement along the coordinate 1. That means what I should call?
F11, sir.
What I should call this? What I should call this? Where I am applying the unit force?
F2 and F1.
Where I am measuring the displacement?
Part 1, sir.
What I should call? I should call this as F2,
1.
right? After that, what I will do? Instead of applying at 1, now I will apply displacement here. Sorry, I will apply unit force here. Then again the deflection is gonna happen. How the deflected shape will be? The deflected shape will be like this. What about this magnitude I should call? Where I am applying the unit force? 2.
At 2, sir.
Where I am finding the displacement? 2. So what I should call this one? F.
F2, 2.
2. What I should call this one? Where I am applying the unit force? 2. Where I am finding the displacement? 1. What I should call?
1, sir.
1.
2.
Now, what is the difference between this case and the previous case?
Size of the matrix.
In this case, we are having static indeterminacy 1. As we are having the static indeterminacy 1, we are applying the force here and measuring the displacement at that point only. But if you come to this case, if you apply a force here, tell me, deflections are possible only at 1 or deflections are possible at 2 also?
2, sir.
Deflections are possible at 2 also, sir.
This is where the difference comes, isn't it? So, if you want to find out the reaction at 1, what we have to do? Net deflection at 1 should be equal to 0. These statements are correct, isn't it? I will say net deflection 1 is equal to 0. And to get the reaction at 2, I will say net deflection at 0.2 should be equal to 0. Is there any doubt in these two statements?
No, sir.
That is what happens, right? As it is a roller support, the deflection 0 at both the supports. No doubt, isn't it? Now, at coordinate 1, tell me how many deflections are possible in the present case. Deflection due to this, isn't it?
Yes, sir.
Two,
And
sir.
what about,
2 possible, sir.
and what about this? It's not due to this reaction, it's about due to the other reaction also. Now tell me, instead of 1, there is a force of R1. Then how much deflection is going to happen here? Previously what we have done, we have applied the unit forces and we have told that the deflection here is F11. Now, instead, if you apply a reaction R1, can you tell me how much deflection is possible here? If you apply unit force, what is the deflection that is possible? F11. Now what I am asking you, instead of 1, or if I multiply with R1, how much deflection is going to possible here? We already discussed that if you apply unit force 2 mm, if you apply a 10 force, how much it will be? 2 into 10.
20.
If you apply multiplied by RB, then what is the net value? Now how much deflection is going to happen here? F11 times R1. What about here? F21 times
R2.
R2 or R1? We are applying
R1,
only
R1.
for
Sir,
R1.
Now instead of 1, if I apply R2 here, then what will happen to this F12? F12 times
into R2.
F22 times,
Into R2.
right? So here the deflection at 1 due to applied forces, due to the reaction at 1, due to the reaction at 2. Now what is the net deflection that I can write down here? Deflection at 1 or due to applied forces.
Equal
Okay.
to.
Now that will be equal to, instead of making everything 0, I'm making this and this equal. What about
Yes.
the deflection due to reaction at 1? F11 times
R1
R1. What is the deflection at 1 due to R2?
plus F12 into R2.
F12 times R2. Similarly,
Delta
what about at 2? If I apply this equation, deflection
F1
at applied force 1. Similarly, deflection at applied force at 2, that will be equal to
F1 to R2
deflection due to
to
R1.
R2.
F21 times R1 plus F2 2 times R2.
R2, yes, sir.
I can write this in terms of matrix size, isn't it? So how this looks like, if I write this in terms of matrix, this I can say, due to applied force along the direction 1, due to applied force along the direction 2. That should be equal to, here also there is such thing, what is it? Here this is R1 and here this is R2. Isn't it? Now, what about this magnitude? If you take common F11, F12, F21, F22. You can multiply and you can see that above equations you can get it. So what is this called? This is what called the flexibility matrix. Same equation that we have applied, delta that will be equal to the flexibility times the reactions or forces. Have you got the same thing or different thing? Same thing, right?
Yes, sir.
It's one and same thing. Either you, I hope you guys find the difference. Now you understood how to apply the force method to find the unknowns. Now, clear? Can I say that F12 is equal to F21?
Yes, sir, equals. Sir.
Can I or I cannot?
No, sir.
Can I say K12 is equal to K21?
Yes, sir. The diagonal elements are same, sir.
Yes, sir, same, sir.
Applicable for flexibility also? Will it?
Yes, sir.
Are you sure it will? If you are having doubt, this I can write it as a 1 by F12. This I can write as a 1 by F21. Even if you simplify this, what you will get? F1 equal to, you will get it obviously. Right? Now,
Yes, sir.
how I should represent F12? F12, where I am applying the force? I am applying the force here, unit force, and then I am measuring the deflection here. How about F21? I am applying the unit force here, and I have to find the deflection here. Can you tell me which one is easy? Finding F12 or finding F21?
Finding F2.
What do you think? Which one is easy?
F1, F12, sir.
Can you tell me what will be the deflected shape here? What is the deflected shape in the portion AB? And what will be the deflected shape in the portion BC? What can be the deflected shape in the portion BC? Can you tell me?
Trapezoid, sir.
What is the shape?
Trapezoid.
Trapezoid. I'm not talking about any bending diagram. I'm talking about the deflected shape.
Sir, triangle, sir.
Let's say this is the point B. Is there any load acting in the portion BC?
No, sir.
No,
If
sir.
there is no load is acting, then this portion will not be left. What will happen? This portion, deflected portion, will be linear. I don't know whether you guys, this thing I've discussed. SOM completed, right, for you? Strength of materials.
Yes, sir.
Sorry for asking so many times because this might have done there. Now, let us say if this is L and if this is L. Or let me compare two things, okay? What about the deflection here? Hope you guys can remember. What is the deflection? It's just simple cantilever, right?
Yes, sir.
What is the formula? PL cube by
6EA.
which EA?
3.
What about the slope at this point? Let us say this is A and this is B. Whatever the slope at that point, theta B. What is the slope? PL square. Quickly tell me, quickly find out what is the slope at point B. I just want to see your reaction.
2E, sir. PL square divided by 2E.
How are you going to find out? What is the simplest way to find out the thing here? Okay, now apply the same thing here. Even if, what is the difference between this case and this case? Just as CB is extended there. So this is how gonna deflect like this, but in the portion BC, as there is no load acting, what will happen? The beam will simply rotate with respect to the slope. So here this portion will be linear. As there is no load acting at point B, BC portion will simply rotate with respect to the slope at point B. Now you know from here to here what is the deflection? From here to here what is the deflection?
PL by 3A.
3EI. And what about this magnitude? This is linear. Let us say that this is the slope theta B. What about this value? Theta B times. That means what about this value? Theta B is PL square by 2A. If you multiply well, how much will get?
PL cubed by 2E.
So what is the total deflection at C? Add the values. That is PL cube by
3A plus
PL cube by 2E. How much it will be?
5 by 68, sir. 5 PL cubed by 68.
Huh?
5 PL cubed by 68.
6A.
PL cube by
6A.
EI. Right? Now, convert this in terms of flexibility. What is flexibility? What is the flexibility? Flexibility is nothing but
Deflection divided by
instead of P, if I apply a unit force. Instead of P, if I apply P is equal to 1, what I can call this delta C? I am applying force at B, unit force at B, finding the deflection at C. What I should represent the flexibility as?
same only, sir.
Where I am applying the displacement? Where I am finding the displacement? C. Where I am applying the force?
This
B. That will be equal to, if P is equal to 1, how this is gonna simplify?
5L cube by
68.
CI. According to the question, we are finding the force, applying the force here, finding the displacement here. Then what I should call there? I should call it as F21.
1.
That will be equal to 5L cube by
6.
E. That means we have found out this, isn't it?
Yes, sir.
As we discussed, this is equal to this. So finding this F21 is easy compared to F12. This you can come from practice of conjugate BC. If you remember these two formulas, do you think really finding the deflection at C is difficult? If you remember these two and if you remember this logic, is it really difficult to get this value?
No, sir.
Right?
Yes,
So that's why I told you that this is easier. Now can you look into the options? The options given as L cube by 3I, L cube by 2EI, L cube by 8EI, and the last option they are given as L cube by 1.2 EI. If I goes to the downwards, then obviously it's 1.2, isn't it?
Yes, sir.
Now you got the idea, flexibility matrix.
Yes, sir.
Any doubt in this whole thing? So sometimes, if you understood the logic, finding this F21, what do you think, how much time it takes? Now tell me, how can you find out F12? How are you going to find out F12? Don't be keep quiet. You should talk.
So you have two.
I mean to say that which method you will use. That okay, let's talk about that later. I think it's clear, right?
Yes, sir.
Let me check your knowledge here. Now here in this case, my requirement is to find the support reactions. Can you tell me which method you are gonna use this? Can you support reactions easily for this case? Which method you're gonna use? Are you gonna use displacement? Or are you gonna use force method? What is the
Which
kinematic
method, sir?
Yes,
force
sir.
method, right? Because what is the static indeterminacy?
1, sir.
One kinematic indeterminacy.
2.
Kinematic indeterminacy. Is it really two? If it is
No,
a
no, sir. No, sir.
6 sir.
at a joint, how many deflections will be there? Two.
Yes, sir.
At a joint, horizontal and vertical, you have there. At A,
1.
at B will be two.
Yes, sir. At A2, B2, C1, D1.
Total four. At D, how many? At D, the
One,
first-
sir.
D1. C1, sir.
it is a truss. If it is a truss, I told you so many times, rotations
Okay,
you
sir.
should not consider. You should not commit this mistake at all.
Yes, sir.
Okay, sir.
Think, inform to your mind that truss one, slopes you will not consider. So total, what is the indeterminacy? Kinematic. At A2 and at B2. So total 4.
4 only, sir.
So generating 4 equations are easy, or generating one equation is easy.
One
One.
equation.
Right now, what I am asking you is that each of you as 3 guys are there. Vishnu, I consider the unknown as reaction at C. That is what your unknown in static indeterminacy. Priyadarshini,
Yes, sir.
horizontal deflection at C. And Ramya, your unknown is vertical deflection at D. Now, each of you tell me the equation or tell me the procedure how you're going to solve it. Take 2 minutes of time. Methodology is same. You understood the methodology for proper cantilever and the what are the example continuous beam that we have discussed? Are you guys clear about it? So just tell me how you're going to find out the things. First of all, let me just hear you. What is the equation that you're going to write it down?
Okay.
You no need to find out any value. First of all, I need you to just write down the procedure that you guys have to do. That's it. If you guys are not trying, let me know. I will discuss. First of all, I just need you to write down the procedure only. That's it. And somebody tell me what is the equation that we should write. What is the first step you have to do? You have on the static indeterminacy and you have selected the unknown. Next step, after the indeterminacies and number of unknowns. What is the next step that you have to do?
Release the reaction,
Release the
sir.
reaction, sir.
Yes. After releasing, that means you will change the support, right?
Yes, sir.
Those who have selected the horizontal reaction at C, which type of support you have replaced it there?
Rollers, sir.
Yeah, roller in which direction? Horizontal direction.
No direction.
Those you have placed considered vertical reaction at C. In which direction you guys have to place the rollers?
Vertical direction.
Vertical direction, right? Now,
Yes, sir.
after that, what you're gonna find out? Deflection. What is the equation? I'm gonna write it down. Deflection at that point. Let us say if I'm considering horizontal deflection at C. How I'm gonna replace? I'm going to replace with this support. Right? Now, what is the equation that I'm going to write it down? Horizontal deflection at which support? D. That will be equal to or plus or minus, doesn't matter, plus flexibility of horizontal reaction at D or flexibility of HD times horizontal reaction at D. That should be is equal to 0. Any doubt in this equation? We have released the force. This is what due to the applied forces. This is what due to the unit force. And then this is what the unknown. That implies HB can be find out as we have discussed. Is it okay? Now, how are you going to find out delta HD? Can you tell me? Have you just forgotten about process? Whatever we have discussed? Okay, at least forget about that. Is it okay? The logic is clear. What are the equation that I wrote? Is that okay?
Yes, sir.
And remaining thing already we have discussed how we have to find out this. And if you know how to find out this, in the same way you should know how to find out this. Why? Because here this is find out by using unit force only. So what I need request you to, I told you for to consider horizontal reaction at C. For one I have told you to vertical reaction at C. For another one I think horizontal at D. So please work out this case and tomorrow or in the next class let me know about these values. If the process is clear, then we'll go to the next topic.
Okay, sir.
Clear, right? So I can move to the next topic, isn't it?
Okay, sir.
Okay, now let us talk about the arches. Now, how you will define or how will you differentiate the arches and the beams? Or if somebody asks you, what is the main difference between the arch and the beam? First of all, if somebody asks,
sir.
suppose if somebody asks you what is the mean by a beam, how are you gonna say it?
It's the flexural member.
It is a whatever the loads that are acting upon, it will resist through which behavior? It will resist through the flexural behavior.
Flexural behavior.
That means what is the flexural behavior? That is through bending. Somebody asked what is mean by arches. So these are compression forces or predominant in the arches. Compression axial forces. So I'm just asking you a common question like, imagine there is a structure of this shape and imagine that there are some roller supports. If I apply a force like this, what will happen at the supports? Will they remain stable or what will happen? Will the supports move? If so, in which direction they move? Either they will move outwards or they will move inwards. Or if they don't move. Imagine practically, if you apply a compression force, how the supports will move. Will they move outwards or will they move towards? Obviously, towards left. Obviously, it will move towards right. That means they are moving outwards, isn't it? To get the stable, we have to restrain the deformation. As it tries to move to the left side, what is the reaction that's going to develop here?
Horizontal.
Horizontal, that is opposite to the reaction. So here, reaction. Have you ever noticed in chair, whatever wooden chairs, if you remember, at bottom you guys might see there is some alignment here. Remember? Why the reason they are connected at the bottom like this with each leg? And in plastic chairs, you don't see this type. Or even if somebody with a heavy weight, if they sits on the top of plastic chair, you can imagine how the legs of the chair will move. They will obviously move towards the outside. So to restrict those type of behavior, generally what people will do in olden days, if it is wooden, legs of the chairs are interconnected with each other so that those type of deformations will be restrained. With the same logic that we are gonna see in arches also. We are not going to discuss any fundamentals of this, like what will be the types of the arch. Either they will be parabolic, or they will be circular, or they will be elliptical. They can be of any shape. They should be of curvy shape actually. And after that, you might see there will be 2 hinge arches, there will be 3 hinge arches. That we'll see what is the indeterminacy of those arches. First of all, if I say this is my arch, and if I talk about, consider one more arch here. If I place a hinge here, obviously here there is a hinge at this point, there is a hinge at this point. That's why we are talking about it is a 2-hinged arch. In this arch, there are 3 hinges, that's why we are calling it as a 3-hinged arches. And if you talk about the static indeterminacy here, as we know, 2 reactions will develop here, 2 reactions will develop here. We are having only 3 equilibrium equations. So that's why what is the static indeterminacy? 1. Even if it is a 3-hinged arches, 2 reactions will develop here, 2 reactions will develop here, total 4. Equilibrium equations are 1. But as there is an additional hinge here, moment at this point is equal to 0. That's why there is an additional equation -1. That will be is equal to 0. So if it is a 3-hinged arches, what is the static indeterminacy?
0.
That means 3-hinged arches reactions can be found out by using the equilibrium equations itself.
Yes.
If it is a 2-hinged arches, then we have to solve it by using some indeterminate. Right? Now, the general representation of why arches are important. If you consider any section here, what is the bending moment? Let us the UDL length of W. Total length is L. Let us consider this section at a distance of X. What about the bending moment at that section? What about the support reactions we know? WL/2. And what about the support reactions here? WL/2. What about the bending moment at that section? Because of this WL/2, what is the moment that will happen? WL/2 into X minus, because of the applied forces. What is the bending moment at this section? Total load is WX X/2. So that will be equal to WL/2 times X minus WX square by 2. Now, if I represent the arch, any arch that either can be a 2-inch arch or 3-inch arch, and assume that the length is L and there is a UDL acting over the beam, arch W, and that is a support A and B. Similarly, what will be the support reactions here? As this is symmetrical, obviously, the reaction will be WL/2. Here also WL/2. As we have discussed, the horizontal reaction will develop here and horizontal reaction will develop here. If I am considering this as my horizontal reaction H, as there are no other applied loads, here also the horizontal reaction is H. Similarly, if I consider there is a section at a distance of X from the left support, what about the bending moment at that section? Because of WL/2, as we know, WL/2 times X, because of the UDL, WX square by 2. And imagine that At that section, the distance is 1. Because of this h, minus h into 1. So, if you compare these two equations, your bending moment is reduced by how much amount? By
That's
an amount
why.
times the y. So here h, this we will represent it as a horizontal thrust. So if your bending moment is reduced, how does it going to help?
Reducing the section size
Yeah,
of the section.
then how to design it for the lesser bending moment? If you are designing for lesser bending moments, obviously the cross sections will be less.
Reduced.
That means it will be economical. That's what we are gonna discuss. But what are the drawbacks that we can see in this case? Okay, that's fine. Your moment is reduced, our cross sections lowered. But this is advantage, right? If your moment is reduced, then you have to go for the reduced sections. But my question is, are you constructing everywhere type of arches, or even the beams only, even in flyovers or everywhere? Are you seeing the arches, or what is the most of the common structures that you are seeing? Even in flyovers, let us
Only, sir.
March on the
that too. What is the cross section that you're gonna seeing there? Are you gonna see the simply the rectangular cross section, solid rectangular cross sections, or are you seeing some other type of cross sections? Have you ever observed the what is the most common type of cross section that people are using nowadays? Let us say, I think metro has come to the, if you, I don't know, I don't remember exactly, if you can identify in Hyderabad or any other big cities, the metros, you guys haven't see the hollow sections. Those are one of the very important structures that people are nowadays as their hollow sections. They have, and the material required will also be less. So if you are coming to the arches, the problem with the arches is that, as I'm telling you, that horizontal thrust should develop. If you're creating a support, if it is not capable of strong enough to develop the horizontal thrust, then it will be of no use. So the amount of horizontal thrust that creates is also, it should be in large amount. That's why what happens is that generally generating or creating that type of support is somewhat complex compared to the beam or normal simply supported case. So this is also one of the drawback, and there will be other drawbacks, that ease of construction, ease of skills, ease of engineering skills. So by considering all those things, keeping in mind, and it also depending upon the length of the span also. If length of the span is not much enough, then constructing of arch might not be of an economical or a efficient option. So to decide or not, it's obviously one of the main factors, spacing between the columns or spacing of span. I have literally observed, I think I have roamed in Hyderabad, I don't know, I have roamed in Tamil Nadu, but in Hyderabad, I can say that there are some spans in metro. Depending upon the span, they have selected this type of arches. I'm telling you, hollow is one of the option. Hollow sections plus arches. They have combined it both. So both will become very, very efficient. Again, I'm telling this again depends upon the span. If your span is larger, then obviously people will go for the arches only. If that two has failed, then people will go for the which type? If arches is not an option, beams are not an option, hollow sections are not an option, then what do you think people will go for the next type of thing? Cables. I don't know whether you guys are observing cables are also having the very much longer spans. So it's upon an economical point, there will be an economical efficient point for each and every one. It depends upon the number of factors. So if something is failed, then only the people will go to the others. So simply, I cannot just say simply H into Y. There will be again a number of factors that will be accounted for, and people will go through all of them and then pick up the efficient output. Right? So that's why everywhere winning moment is reduced. It doesn't mean that everywhere I can see the arches everywhere. The practical from now onwards, I think you guys have to observe the structures that are building in your surroundings or in the nature, because that's where we can learn a lot of things. What are the updates that are going on? Yes, we have to observe the things and note it down what are the improvements that are happening. Those things will be very much used. Theoretical studies, everybody can debate. The knowledge for civil engineering, it obviously comes from the site only. Keep that thing in mind. Okay. Now, let us start with the simple thing. Before that, if it is a parabolic arch, and let us assume that the peak summit is represented by H, and if I'm representing the coordinate of any point, if this is along X, and if this is along Y, and if this is obtained by using the, or if there is a parabolic arch, then the ordinate of Y on the point of arch that can be obtained by using this equation, OH by L square X times L minus X. This equation, I think you guys should remember. This is from one of the supports X and Y. What about if it is a circular? Even though it's not exactly circular, please imagine that it is circular, just for my help. If it is a circular, whatever this represents, radius, whatever this represents, radius, and whatever this represents, radius. Now, how can I find out the coordinates of any point? This can be found out by using the angle. If this angle is theta, can you tell me what about this? From here to here, we know what about this magnitude R. Can you tell me what about this magnitude R sin theta? And what about this magnitude R cos theta? So if I'm representing my X and Y from here, what will be my X? My X from here to here, how much it will be? From here to here, the radius minus from here to here, R cos theta. That means my X coordinate is denoted by 1 minus R cos theta. If it is Y, that is nothing but your R sin theta. Let us say if this is A and if this is B. Tell me if theta is equal to 0. That means at what point I am going to find out?
Point, sir.
At what point? At point A, right? If this is your arch, if theta is equal to 0, where this arc meets on the arch at this point. If you're talking about some angle theta, where the arc of the circle meeting on the arch here. So if this theta equal to 0, that is meeting at the point here A. So if you can see, if theta is equal to 0, cos 0 is 1. What about X? 0. What about Y? 0. It's just like I'm just explaining whether they are satisfied or not. If I want to find out the coordinates of point B, what is the angle that I should consider? If I want to find out my coordinates of B, what is the angle I have to consider? If I'm talking about here, I'm talking it as 0. If I talk about at the peak, what is the angle that I should consider?
90 degrees.
Then what about at B? If it further goes to that side,
180.
get to here 180. Now, let us take a simple example. Load is W, or let us say 10 kilonewton per meter. And let us say the peak is 3 meter. The length is 5 meter and 5 meter. And I think the support reactions, you can tell me right quickly. What are the support reactions that I can say?
Vertical.
WL by 2. So total load is, intensity is W. And what is the total span?
10.
By 2. That is nothing but a 50 kilonewton by taken by support A. 15 kilonewton taken by support B. After that, as this is symmetrical, I can say if the H reaction is acting towards the joint. Similarly, the H reaction will also acting towards the joint. Why? Because there are no other horizontal forces. At these two, you should get it as 0. Now tell me, how can I find out this magnitude?
By taking moment.
Moment, sir.
That is a hinge point.
See.
Is equal. Can you tell me what is the equation that you will get here?
50 into 3. 50.
Because of 50, what is the moment? 50 into
5.
5. Anti-clockwise, right? That is anti-clockwise is negative.
Minus 50.
Plus, because of horizontal reaction, H into what is the perpendicular distance? 3.
3 meters.
Anti-clockwise. Similarly, because of the UDL, clockwise. Positive 10 into 5 into
10 into
we are talking only of the span. 10 into total length 5 into 5
5
by
into 5.
will be equal to 0. From this, what is your reaction H? How much you are getting? I can do the simple calculation, right? Now, imagine again there is a circular arch, 3-hinged circular arch. This is nothing but a parabolic, and again the length is L, L by 2 and L by 2. Sorry, 3. And the load acting on this is W. So again, I'm doing the same thing. Can you tell me what about the reactions here?
Vertical.
Same, right? It will be WL by 2.
WL by 2. W by
Can you quickly tell me what will be horizontal thrust? Can you please do the calculation part? That is, this is the point C, point A, point B. That is there, the height is H. Central rise is H. Can you tell me quickly find out? Take moment at point C is equal to 0. Can you quickly tell me what is my horizontal thrust? W.
L square by 4H.
W L square by
4H.
Is it right? WL square by 4H. Can somebody please verify? Is this right or wrong? Is it okay? WL square by 4H. Are you getting the same?
No, sir. 1 minute, sir.
How much? Please confirm this value.
1 minute, sir.
Please confirm this value. How much we are getting? WL square by?
1 minute, sir. 1 minute, sir.
Yeah, fine.
Yes, sir. W is 4H.
So what is the equation that we get because of WL by 2? WL
WL by
by
2 into WL by 2. L by 2.
anti-clockwise, right? So minus, because of the loading, clockwise, positive. Double
H into UDL missing. UDL missing.
by,
W.
have you considered L by 2 or L by 4 here?
L by 4, sir. L by 4.
L by 4, right?
Yes, sir. Yes, sir.
Clockwise, which will be equal to 0. So what about this value? Minus WL square by 4 plus WL square by 8. What about the capital H then?
UDL missing, sir. UDL.
UDL?
We missing UDL load, sir. That's it.
UDL load I have considered, right? WL by 2 into L by 2.
Yes, sir. We both missing that UDL.
This is reaction, this is reaction UDL support. Have you missed anything?
No, sir. You
guys got 4H. You didn't take 8H. Who is done wrong then? Like, why you guys are getting 4H, let me know. Where is the mistake that you guys have committed?
we are missing the UDL, sir.
Am I missing or you are missing?
We missing, sir. We missing UDL, sir.
Right into L by 4, right? But how much you guys have considered there then? In this part, how much you guys have considered, I don't know. Achha, you guys are not taking this load at all?
Yes, sir. We are not taking that load.
That's fine. Now, what you do is that now take a section somewhere around here at a distance of x from this support and find out moment at that section. You know the rise. What is the y? If it is a parabolic, I can represent it by using 4h by L square into x into L minus x. Now, write down this bending moment equation. Moment at any section xx. And simplify the equation and let me know how much you are getting. This kind of practice for you also for solving the problems. Please try it and let me know. Write down the moment at any section xx. And let me know if you guys are facing any troubles.
In bending moment any side,
You are?
we're taking a bending moment any side, it's not problem, sir.
You can look it on any side. It's better you should look on from left side.
Left side, sir.
Look from left side and write down the bending moment equation.
Okay, sir.
How much you are getting? Please try it and let me know. How much you are getting, guys? Shall we continue on the next class? Meanwhile, you tell me this value, okay? Solve the problems.
Sir, WLX divided by 2.
W.
LX divided by 2.
What
HA
about this? See, as we are not going to discuss not many problems, that's why I'm asking you. That is a WL by 2 into x, right? Clockwise.
Yes,
And
sir.
okay, because of this
Minus HA into Y.
WL square by 8h into y. What is the y I can represent? 4h by L square into x into L minus x. And because of this UDL also, negative WX into x by 2. Here see, HH gets cancelled, L square gets cancelled. This can be 2 times. So if you simplify this, how much will get it here? W into L minus x. W Lx by 2. If you expand this, minus WLX by 2, minus into minus plus, WX square by 2, minus WX square by 2. How much you are getting? 0.
0.
How come you are getting the value? So what is the logic that we can understand here? Here, the shape of the arch is matters. So if it is a UDL loading on the beam, what is the shape of the bend? If it is a UDL, what is the shape of bending? Can you tell me what is the shape of the bending moment diagram? There is a simply supported beam. UDL load is acting over the beam. What is the shape of the bending moment diagram?
Linear, sir.
Linear. Parabolic, sir. Parabolic.
Nothing. Parabolic. What is the degree?
Yes, sir. Parabolic, sir.
0.
Parabolic, sir.
Force x to the power 1. Bending moment
Answer.
x to the power 2. If
Yes,
it is
sir.
a point load, what is the shape of the bending moment? If it is a point load, the shape of the bending moment is
Linear, sir.
Linear, sir.
if you construct the shape of the arc corresponding to the shape of the moment, then
Sir.
your bending moment is equal to 0 anywhere.
Yes.
So it is also one common type of 1 mark question that will ask in the exam. That if your shape of arch is in the shape of equivalent BMD of simply supported beam, then the bending moment is equal to 0. So these type of arches are generally called linear or theoretical or funicular arches. That means what is the shape of the arch? Shape of the arch is in the form of equivalent bending moment diagram. If the arch is constructed like this, imagine if the arch is constructed like this, load P. What do you think bending moment everywhere? If it is a simply supported subjected to point load, what is the bending moment? If it is a simply supported subjected to point load, what is the bending moment diagram?
Linear, sir.
Triangular, right? The whole diagram is on the form of triangle.
Triangle shape.
If I construct the arch in the form of triangle subjected to point load, then bending moment is equal to 0 everywhere. And if they ask you to find the reactions, can you find the reactions here? Vertical reactions can be found. Then what about horizontal reaction? For finding horizontal reactions, you can take moment is equal to 0 everywhere. Even though they don't represent the hinge here, but according to the shape of this structure, we know that bending moment is equal to 0 everywhere. Then you can find out this horizontal thrust without any using additional equations. Is it okay?
Yes, sir.
Okay. Let's stop here and you guys solve some problems and we'll continue in the next class. Okay.
Yes, sir.
Okay. Thank you for today and let me know if you have any doubts.
Sir, when we have next class, sir?
Sorry.
When we have next class, sir? Next class.
Still, I could not understand.
Sir, when we have next class, sir?
I don't know, yeah, but let's see.
Yes, sir.
And one doubt, sir. What is the relative stiffness, sir?
What is the?
Relative stiffness.
Let me tell you. Just a second. So what happens? See, if R is fixed, what is the stiffness we are talking about?
4EI by L, sir.
R is spin
3EI,
3L, right? So let us normalize with 4EI or 4. How much you will get it? If you normalize with 4E, then how much it will be? Everywhere divided by 4E. I by L, and here it will be 3 by 4 I by L. So sometimes instead of taking the complete stiffness, what we are doing, you can take relative stiffness, that is I by L and 3 by L. That means if R is fixed, you can take the relative stiffness as I by L. If R and is friend, you can take the stiffness as 3 by 4 I by L. Now you should ask me one doubt that why I have divided with E only. Why not I have divided by I? Have you ever got this question? I'm asking the proper question. Even in your textbooks, you can see, right? I by L and
Yes, sir. Yes, sir. That's why. I'm asking, sir.
like 1 by L and 3 by 4 by L, 3 by 4 L.
Yes,
Why
sir.
not they have divided by I? Why not?
I don't know. Sir.
No, I'm just asking you in curious. I is depending upon cross section. E is depending upon the
Material.
material. So in general, what happens is that
Material is
cast-
constant everywhere.
in general or most of the times, you will cast with the same strength of the material at a particular level of flow or
Yes.
for a particular level of wave. But the cross sections can be changed from one section to the another section. So that's why usually the people will divide with by E. Why? Because is that the strength of the material will be treated as same, but the moment of inertia or the sections can be different. So that's why people are not generalizing with respect to I, but they have generalized with respect to E.
E.
Clear?
Yes.
Okay, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.